Hey everyone, in this video we'll be graphing different types of functions. As you can see, I have my grid lines and my graph right here. And the first type of function that we'll be graphing is called a constant function. So a constant function, let's define a function f of x equals c. So c right here, let me actually make that a different color, c. C is any real number. It is any real number. So let's just define c. Let's say c equals 3. So c equals 3. In other words, f of x equals 3. F of x equals 3. Good. So f of x equals 3. And before we graph it, let me just move that just a little further up. F of x equals 3, or let me actually just rewrite it down here. So f of x equals 3. And how do we graph this? So f of x equals 3, well, this is actually just a horizontal line. If we think of f of x equaling to y, remember on a graph y equals f of x, this is actually just y equals 3. So y equals 3, this is a horizontal line, and we know how to graph those. We're going to start on the y-axis at y equals 3, and we are going to draw a horizontal line. Let me just do a better job of drawing that line, make it as straight as possible. And it is going to be a horizontal line at y equals 3. And there we go, we have graphed our constant function. F of x equals 3. Now, what makes this function constant? Why is it constant? Well, let's do this. Let's try to take f of 1. So let's try to take f of 1. How do I find f of 1? Well, right here, f of x, at f of 1, where x equals 1, let's go ahead and find 1 on the x-axis right there, and draw a dotted line to see where it touches the line. And there we go. It touches the line at 3, right here, 3 on the y-axis. So f of 1 equals 3. Let's try to find f of 2. So f of 2 will do the same thing. We'll find 2 right here on the x-axis, and we'll draw a dotted line going up until we hit the function, the orange line. And there we go. It also has a y-coordinate of 3. So just to be clear, this first one is 1, 3, and this second point is 2, 3. So in both of these cases, the y-coordinate is 3. So f of 2 equals 3. And the reason why this is a constant function is because f of any number is 3. It doesn't matter what the x value is, the f of that number will always be 3. So f of x equals 3 right here. X can be anything. It can, f of 100, we know, is going to be 3 as well. F of anything will be 3. So that's what makes this a constant function. Constant means unchanging. It does not change. So that is how we graph a constant function. F of x equals c, and c is any real number. In our case, we chose c to be 3, so we drew the function f of x equals 3. So that's one type of function, constant function. And let's discuss another type of function. This is called an identity function. So identity function. So an identity function takes this form. It takes the form f of x equals x. So let's go ahead and actually draw this line. So f of x equals x. Well, we know y equals f of x, so this is the same as saying y equals x. And y equals x, let's go ahead and plot it. So at x equals 0, right here, so x equals 0 right here, what is y? So at x equals 0, that means y is also 0, so our first point will be right there. At x equals 1, y will be 1. At x equals 2, y will be 2. At x equals 3, y will be 3. And it is just actually, it is a linear equation right here with no x-intercept, or with no y-intercept. So if you think about the form y equals mx plus b, what is b right here? Plus b. In this case, there is no plus b, so b in our case is 0. So that means we start at the y-intercept at y equals 0 right here. And what is m? Well, there's no coefficient in front of it, in front of the x, which means the m is 1. M equals 1. So that means it has a rise and run of 1 over 1. So 1 up, 1 over. 1 up, 1 over. 1 up, 1 over. 1 up, 1 over, 1 up, 1 over. And let's go the other way too, starting back at 0, 0. Down 1, down left. Down 1, down left. Down 1, down left. Down 1, down left if we go backwards. And then let's connect all these points together with a straight line. And there we go. We have drawn the function f of x equals x. So what is, for example, f of 1? What does f of 1 equal? Well, okay, f of 1, if x equals 1, then we'll find 1 on the x-axis and we'll go straight up and we hit this point that has a y-coordinate of 1. This point is 1, 1. So our y-coordinate's 1, so f of 1 is 1. Good. And let's find f of 3. So f of 3, same thing. 3 is right there. We'll draw a dotted line going up till we hit the line. And at this point is 3, 3, because it touches 3 on the y-axis as well. So 3, 3. So f of 3 is 3. And you might notice a pattern. F of x equals x, which is the identity function right here. That means f of any number is that number. So your output is the same as your input. And that also means, because our output is the same as the input, we can guess f of 100 to be just 100. F of 100 is 100. Remember to think of functions like a machine. We put in 100 right here, so our input was 100, and our output is also 100. It's the same thing as our input. That's the identity function, f of x equals x. So that's how identity functions work, and that's how you graph it. F of x equals x. Now let's move on to the next type of function, the absolute value function. So let me write that down. Absolute value. And it takes the form f of x equals the absolute value of x. How do we graph this? Well, f of x is the absolute value of x. So let's actually just graph a few points. Let's try a few x coordinates. X equals -2, -1, 0. And let's see what f of x is. So let's try the first one. At f of x equals -2, what is f of -2? So f of -2 equals, if we take this right here, f of x equals the absolute value of x, then f of -2 equals the absolute value of -2. What's the absolute value of -2? That's simply just 2. So f of -2 is 2. Good. What's f of -1? We'll do the same thing. F of -1 is the absolute value of -1. So the absolute value of -1 is +1. Good. And what is f of 0? So right here, f of 0 is the absolute value of 0. Absolute value of 0 just comes out to 0. Great. So let's graph these points right here. -2, 2. So let's go ahead and graph that. -2 on the x, 2 on the y. That's -2, 2. That's our first point right here. -1, 1. So -1, 1 is here. Good. 0, 0 is right here. Good. Now let's draw, or let's use different x values. Let's have 1 and 2. So what's f of 1? So this one right here, what is f of 1? We're trying to find f of 1 right here. So f of 1 equals, again, following our function right here, f of x equals absolute value of x. F of 1 is absolute value of 1. Absolute value of 1 is 1. So this is just positive 1. F of 1 equals 1. And same thing with the f of 2. F of 2 equals the absolute value of 2. Absolute value of 2 is just positive 2. So f of 2 equals 2. And let's go ahead and graph these points. Or plot these points right here, 1, comma 1. This first one is 1, comma 1, which is right here. And then 2, comma 2 is right here. And that's the second one. And there we go. Let's connect all these points together. So let's connect all these points using a line like this and a line like this. And there we go. That is an absolute value function. And you'll notice it has a V shape. It is shaped like a V. And that is how an absolute value function is graphed. And then you can use this function right here to evaluate higher values. So if you wanted to find f of 100, you know that it's the absolute value of 100. The absolute value of 100 is simply just positive 100. So again, looking at this graph right here, if we wanted to know f of 3, so f of 3, what we're going to do is we're going to find 3 on the x-axis, draw a dotted line up. It looks like it hits this point right here. This point is 3, comma 3. The y value is 3, so f of 3 equals 3. And there you go. That is an absolute value function. Now let's talk about the next type of function, quadratic functions. So quadratic functions. So a quadratic function, it takes the form f of x equals x squared. And let's go ahead and just, let's create a table, x and f of x. And let's come up with the values. So with -2, -1, 0, 1, and 2. Okay, so let's find each of these. If we know f of x equals x squared, then what is f of -2? So f of -2 equals, well, that's -2 squared. And what's -2 squared? That is positive 4. Good. So let's actually just make that a different color, just to make that pop out. So f of -2 equals -2 squared. -2 squared is positive 4. There we go. What's f of -1? So f of -1, let's write that down to evaluate it. F of -1 is -1 squared. -1 in the parentheses squared is positive 1. That's 1. What's f of 0? So f of 0 is 0 squared, and 0 squared is 0. What's f of 1? So f of 1 is 1 squared, which is 1. And what's f of 2? F of 2 is 2 squared, which is 4. Good. So we have all these points, and let's go ahead and plot them. So we'll start with -2, comma 4. -2, comma 4 is up here. -1, comma 1 is here. 0, comma 0 is here. 1, comma 1 is here. And 2, comma 4 is here. Great. And let's connect all these. And as you can see, a quadratic function has a sort of U shape. And this U shape, so this is f of x equals x squared. This U shape has a special name. It is called a parabola. parabola. So functions with this special type of U-shape, they're called parabolas. And that is how we draw the function f of x equals x squared. So let's move on to the next type of function. Let's get rid of this. Just clean this up. Okay, so the next type of function, it is called a cubic function. So this is a cubic function, and it takes the form f of x equals x cubed, x to the third power. So f of x equals x to the third, or x cubed, a cubic function. Let's go ahead and plot it. So let's draw our chart again. So x, f of x, and let's draw it at -2, -1, 0, 1, and 2. So what's f of -2 right here? So f of -2, so f of -2 equals, let me actually just rewrite this. So let's actually evaluate them down here. So f of -2 equals -2 cubed. And -2 cubed is actually -8 because it's -2 times -2 times -2. So -2 times -2 times -2. What's -2 times -2? That is +4. And what's 4 times -2? That is -8. So -2 cubed is -8. So we have -8 here. And let's just keep evaluating. What is f of -1? So f of -1 is -1 cubed, which is -1. Now what's f of 0? So f of 0. F of 0 is 0 cubed, which is just 0. Good. And f of 1. F of 1 is 1 cubed, which is 1. Perfect. And f of 2. So f of 2 is 2 cubed, so 2 to the power of 3 is +8. There we go. We have these points. And let's go ahead and plot them. So -2, comma -8. Our graph actually isn't big enough to handle -8, so I will actually just plot it up here. So -2, comma -8. I will plot that somewhere down here. And let's just plot the rest. -1, comma -1 is here. 0, comma 0 is here. 1, comma 1 is here. 2, comma 8. Again, we don't have 8, so I'll plot it up here. So then let's connect this. So it goes up in this direction, and it goes down in this direction. So this is a cubic function, and it takes the form f of x equals x cubed. That's f of x equals x cubed, and that is how it's drawn, and that's what it looks like. Perfect. So let's move on to the next type of function. So the next type of function we will talk about are reciprocal functions. Reciprocal. So a reciprocal function, and let me actually just erase this just for now. Let's get rid of this as well. Okay, so a reciprocal function takes the form f of x equals 1 over x. F of x equals 1 over x. So how do we evaluate that? Let's go ahead and figure out f of... So let's just draw a chart. Let's say we had 1 and 2. So, okay, what's f of 1? F of 1 equals 1 over 1. Because f of x right here is 1 over x. So f of 1 is 1 over 1. So what is 1 over 1? That is just positive 1. 1 divided by 1 is 1. So f of 1 is 1. Now let's do the same thing. F of 2 is 1 over 2. What's 1 over 2? 1 half. So we will write down 1 half. 1 over 2, 1 half. Okay, so let's actually just plot these points. So we have 1 comma 1, which is right here. That's good. And we have 2 comma a half. So 2 comma a half, which is right here. It's between 0 and 1. Okay, there we go. Now let's actually plot a few more. Let's plot a half, if x is a half, and if x is a fourth. So what is f of 1 half? F of 1 half. F of 1 half, let's just make that a different color. F of 1 half equals 1 over 1 half. So we have a fraction in the denominator of a fraction, 1 over 1 half. What does this mean, 1 over 1 half? This is 1 divided by 1 half. Remember, when you're dividing fractions, this is the same thing as 1 times the reciprocal of 1 half, which is 2 over 1. So 1 times 2 is 2. So 1 over 1 half is actually just 2. Therefore, f of 1 half is 2. And a quick shortcut to this, whenever you see this situation of a denominator that is a fraction, what you can do is actually just bring the denominator to bring this fraction to the numerator as long as you flip it. So this would become 1 times 2 over 1. And let's just take that shortcut with f of 1/4. Let's figure that out. F of 1/4 is 1 over 4, which is 4. There we go. 1 times 4 is 4. Okay, great. So at x equals a half right here. So x equals a half. So x equals a half, that's like right here. F of a half is 2. So right there. And then at x equals a fourth, which is even further right there, f of 1/4 is 4 up here. There we go. And let's connect these points. It's going to be curved. And that's the positive side. Let's go ahead and just do the negative side quickly. So let's say we had negative a fourth, negative a half, and then negative 1 and negative 2. So let's just do the same thing. What is f of negative a fourth equal to? F of negative a fourth equals 1 over negative 1/4, which is negative 4. This is negative 4. You could probably guess f of negative a half is negative 2. And then let's do f of negative 1. Let's evaluate that. F of negative 1 equals 1 over negative 1. 1 divided by negative 1 is negative 1. Then f of negative 2. So f of negative 2 is 1 over negative 2, which is negative a half. Negative a half. Great. And let's go ahead and plot all these points. So negative a fourth, comma, negative 4. So negative a fourth is here. Comma, negative 4, which is, I'll extend this a little bit, is down here. So negative a fourth, comma, negative 4 is right here. And negative a half, which is right there, comma, negative 2, so that's right there. And then negative 1, comma 1 is right there. And then negative 2, comma, negative a half. So negative 2, comma, negative a half is right there. And this follows the same sort of shape. So let's go ahead. The same sort of shape as the positive side, is just a little reflected. So there we go. These two curvy lines right here represents f of x equals 1 over x. And that is a reciprocal function. Great. So let's go over the last type of function we'll be covering, square root function. So square root function. So a square root function takes the form f of x equals the square root of x. Perfect. So let's go ahead and graph this. Let's just pick some points for x, and we'll pick some points for, or we'll evaluate what f of x is. So let's do 0, 1, and 2. And 1 and, let's actually do 4, because the math will work out. So let's evaluate the first one. What is f of 0 right here? So f of 0. So f of 0 equals the square root of 0. Remember, f of x is the square root of x right here. So f of 0 is the square root of 0. What is the square root of 0? That is 0. So f of 0 is 0. Perfect. And what is f of 1? F of 1 is the square root of 1. What's the square root of 1? That's 1. Good. And now what's f of 4? And you'll see why I went straight to 4 instead of 2, because it's a perfect square and it'll make the math easier. But f of, f of 4 equals the square root of 4. Square root of 4 is 2. There we go. And let's go ahead and plot these points. So let's plot these points right here. So 0, 0 is here. 1, 1 is here. So we already plotted these. And then 4, 2 is over here. So this is the shape that the function takes. This is f of x equals the square root of x. There we go. And we plotted that as well. And that's the function. F of x equals the square root of x. And one thing you might notice is, let's try to evaluate this function with a negative number. So f of negative 1 equals the square root of negative 1. So the square root of negative 1, we know is I. Square root of negative 1 is I. It's an imaginary number. But we can't plot I here, because this is a graph that only has real numbers. The x-axis and the y-axis, they are all only real numbers. So we can't plot I. So that means any negative numbers, any, those are out of the domain. This function right here, it cannot have any negative inputs. If x is negative, then this function won't work. We can't take the square root of a negative number, at least on the real plane. We'd have to go to the imaginary numbers and plot them on the complex plane. So that is the square root function. That's the last type of function. And these are all the different types of functions. That's how you graph them. That's what they look like. I hope this video helps. And if you have any questions at all, please leave them down in the comments below. And thank you for watching.